Okay, so we're going to look at standard deviation and variance. So our learning target is I can find standard deviation and variance. So the first thing we're going to do is we're going to look at the two data sets below. What is the mean of each data set? So remember, mean, we're going to add them all up and we're going to divide by how many there are. So when you do the first one, I get the mean is 14. And then for B, I get the mean is 14. So when you answer a question like this, which one is more spread out? It's really your opinion, because you could say that they're both equally spread out because they have a mean of 14, or you could say that B is more spread out because it goes from 12 to 19, so you could reference the range. So it's open to interpretation as long as you cite something as evidence, like I think they're both equal because the means are equal. I think B is more spread out because the range is more spread out, something like that. Alright, so standard deviation. Perhaps the most common measure of the spread of data is standard deviation. So example, consider the data on the minutes spent texting for 9 students. So this is what we observed. You can see it. There's a dot plot for you. So notice that it goes from 20 to 90, so we got a pretty big range. First thing we're going to do is we're going to calculate the mean. Anytime you see this symbol, it's an X with a little tilde over it, that means mean. So if I add all these up and I divide by 10, I get 50, so the mean is 50. Alright, so we're going to calculate each deviation. And what I mean is, we observed 20, but we know that 50 is the mean. So just always, you can do this positive or negative. So 30. I mean, it's negative 30 technically, but we're going to always make it positive anyways, so I'm just going to put 30. Alright, the next one, 20 minus 50, 30 again. 30 minus 50, I get 20. 40 minus 50, I get 10. So I'm going to go ahead and do the rest of these. So it's how much it's deviated from the mean is what you're doing. Alright. So deviation is observation minus the mean. This is how you get it. For step 4, we're going to find the average squared deviation. So if I square the deviation, here's what I get. 30 squared is 900. 20 squared is 400. 10 squared is 100. 0 squared is 0. 100. 400. 900. 16. So variance is the average square deviation. So I'm going to add these all together and I'm going to divide by how many there are. This number that you got is called the variance. So I got 540 is my variance. In order to find standard deviation, you take the square root of the variance. So this is the Greek letter sigma. It represents standard deviation. If I do the square root of the variance, I'll get my standard deviation. So 23.24. Alright, so lots of symbols that they'll use, Greek letters. You just have to know what it's talking about and know the formulas for finding them. Alright, so let's talk about the difference between standard deviation and variance, because it's a little weird. Alright, so first, the standard deviation is how spread out the numbers are. The symbol that we use for it is that Greek letter sigma, and the formula is like this. So the square root of the variance is what we're doing. Alright, the variance is the average of the squared difference from the mean, which is what we just did on the other page. So the symbol for variance is sigma squared. Alright, now the formula is really crazy looking, so I just want you to see what it looks like. So sigma, which means the sum x minus mu squared over n. So mu is the mean, x is the data point, and n is the sample size. So what it's really saying is whatever the data is minus the mean, and then square it, add them all up, divide by how many there were, that's how you get variance. That's a really crazy looking formula to show you exactly what we did over here. We found the mean, we did the data point minus the mean, then we squared it, and then we found the average. That's what this formula is saying. Exactly what we just did. So if the formula freaks you out, go back to the problem we just did that you were okay with and you're good. Once you have the variance, you take the square root of it. That's how you get the standard deviation. So in the past, you've talked about center and spread. Now, like in elementary school, middle school, you looked at median and IQR, which is when you do those box and whiskers plots, stuff like that. Or you can look at the mean, or you can look at the spread, like standard deviation type stuff. Alright, so here's your advantages and disadvantages. If you're looking at median and IQR, it's resistant to extreme values. But the disadvantages is it doesn't use all your values. Because remember, when you're looking at a box and whiskers plot, you're looking at 5 main points. You're not looking at everything, really. When you're looking at mean and standard deviation, it's better with normal distribution. So if things are symmetrical, it works out better to look at these. Sensitive to extremes. So these are both talking about the measure of center and the spread. If you're using a box and whiskers and your data has a lot of outliers, then it works good. If you're using the stuff that we're going to start talking about, it's better if you don't have a lot of outliers, and it's called a normal distribution. So all of the data is kind of symmetrical and together. They both mean the same thing. They're both useful. It's just sometimes one is better to use than the other. Alright, don't worry so much about this. So the standard deviation can tell us how close a value is to the average. For example, if the mean of a set of test scores is 90, the standard deviation is 10. So a score of 80 would be one standard deviation below the mean. Here's what I'm saying. Right here's the median and the mean. And the standard deviation, how much it changes. If you go down 10, this would be 1 sigma away from the mean. A score of 100 would be 1 above the mean. So 1 standard deviation above the mean. So 100, 1 above. 1 below, 1 above. And this is what's used when you do things like EOC and you say you norm the curve. You want everybody to fall within so many standard deviations of everybody else. And that's how you get a curve the closer you are. Okay, anyways, we'll talk about this in a minute. So, how many standard deviations would a score of 70 be? So if you went down one more, it would be 2 below. And you're going by tens. Alright, so we're going to learn more later on calculating standard deviation from a mean and stuff like that. So this is just going to be basic stuff. Alright, so whether you're finding the standard deviation for a population or sample, the concept is essentially the same. Okay, so what I did is I wrote down for a population. So now let's look at what it looks like for a sample. It's going to look scary. I'm sorry. Whew, okay, take a deep breath. It's going to be okay. We're going to do some examples. Alright. So example. Step 1, we're going to calculate the mean for the sample data set. So we have 10, 11, 12, 13.5, and 18. If I add those up and divide by 5, I get 12.9. Not too bad, we're good. Now I'm going to calculate each deviation. So I'm going to do 10 minus 12.9, 11 minus 12.9, 12 minus 12.9, you get the picture, 13.5 minus 12.9, 18 minus 12.9. It does not matter if you're using positives or negatives, because we're about to square them, so it's not going to matter. Alright, so here's what I get. And now I'm going to take those deviations and I'm going to square it. So I'm using my calculator. Don't have to do this in my head. Please don't try it. Alright, here's what I get. Okay. So, we found the mean. We're good. We've calculated the deviation and we've squared it. So now we're going to find the average squared deviation. So we're going to add up all the deviations. And the only difference between a sample and not a population is my bottom number is not going to be how many there are. It's going to be how many there are minus 1. So a little weird. So notice there are 5. 5 minus 1 is 4. So I'm going to add up 8.41 plus 3.61 plus 0.81 plus 0.36 plus 26.01, and because I'm not doing a population, I'm going to divide it by 4, because that's what the formula says. Okay, so when I do that, I get 9.7975. I wrote that really ugly. Let me try again. 7975. Alright, so now we have the variance, and to find the standard deviation, we're just going to take the square root of that number. So you get 3.13. The only difference, I can't stress this enough, is that if you're not talking about a population, you're talking about a sample, when you divide and you're doing the variance, you divide by the number you have minus 1. Alright. So, let me know if you have any questions. It's a little hard getting used to, I know. You can watch this video as many times as you need to, and you can ask me for help.